I've been playing Build-A-Boat for years. I used to build sloppy boats when I was younger, and then eventually lost interest. I came back to the game when I discovered mini-games and AFK farms, but I eventually lost interest again. But this time, I've come back because a very interesting update caught my eye. Logic blocks. Something I've been obsessed with since the Little Big Planet days. I also discovered that these existed around the time I watched Matt Batwings' Redstone computer series, so it felt like I just had to do something. But I didn't because I was already busy with other projects. But now I'm not, and it's time to build a working 8-bit computer in Build-A-Boat for treasure. I've only worked on this project for a couple of days so far, so I don't have that much to show yet, but it still feels worth presenting the concept and the progress. This group of signs over here represents all the parts of the computer. I'll go over each part briefly. All of these components here will become the CPU. The adder and subtractor will, add and subtract. The bitwise calculator will run comparisons between individual bits. The instruction center is the set that'll hold all of our instructions. The data register will hold values when we're running a program. The clock sends pulses to all components with a set delay while a program is in progress. The program assembly holds the instructions for the currently running program. The program counter counts the progress of the program, and the flip bridge is for inverting bits. And that's the whole CPU. After the CPU is when I'll make the program storage, which is actually where I write the programs and store them for later use. Of course, I'll need a screen for the computer so you can actually see, and I'll need a GPU to process those graphics from machine code. I'll also need a port for the controls so the computer can actually be interacted with. And I'm not completely sure if I'll add this, but it would be nice to have an audio processor just to give the programs a little more life. And really, that's all I need, I think. I can just add or remove parts later if I need to. And I'd also like to mention that I'm not even close to a computer science professional. This is all just for fun, and I greatly appreciate any advice. And that being said, I'll now go over the components I've actually built so far. This is the 8-bit adder and subtractor. It adds or subtracts input 1 from input 2. Over here, if I put a 1 in both sides, it carries over to the next digit. Here's 1101001 plus 1001010, which comes out as 10110011. Now if I go over here and turn on subtract mode, a carry-in is added to the first digit and the entire second input is inversed. I'll do 1100110 minus 101001. This comes out as 111101. And that's the adder. This is the bitwise calculator. It takes two 8-bit inputs and runs each bit against each other in one of three conditions: AND, OR, and XOR. I'll put 11110000 in input 1, and I'll put 01010011 in input 2. This is the result when I check for AND, when I check for OR, and when I check for XOR. And that's all. The bitwise calculator is quite simple. This right here is the flipper. It just inverses each bit. With these two together, I effectively have a bitwise NAND, NOR, and XNOR by running values through the bitwise calculator and then through the flipper. I'm not going to bother to showcase this one because it's self-explanatory and I ran out of switches because I'm broke. This mess of wires is the data registry. It stores 8-bit values in registers where I can write to and read from each one. There's only 2 registers right now because I ran out of gates and I'm broke, but I can always add more whenever I need to. I'm going to set the destination to 1 and then set the input to 1010, and now I'll hit write. Now I'll set the destination to 2 and I'll set the input to 101 and I'll hit write. Now if I switch back to register 1 and I hit read, we get the value I put in for register 1. And over here if I switch the destination to 2, the same thing happens. And that right there is the data registry. Also, just a side note, I actually already did have a screen in place, but I removed it because I noticed something very weird about these display blocks here. When you activate an input, the block will switch to the color of that input. But as you can see, there's a very clear delay between activating the input and the input actually going through. And the weirdest part is, if I were to switch to one input and then switch to another too fast, it would never even change at all. Hold on. There we go. So basically this thing is garbage and unusable. I'll find another method of screen later. But this is only the beginning. I'll get my money up and build every component from the ground up until I make this computer run the one game I've been anticipating most: Geometry Dash. I don't know why I chose Geometry Dash, but this journey won't be over until I make it. That's all, bye.